total experiment disclaimer, so on. So let's hit the go live button and we'll go from here.
Right on.
What's up, everybody? Welcome to the Juju Show number 48, also known as Rick Plays with New Toys Day. So, YouTube is killing off the Hangouts on Air, which we normally use for the Juju Show, and so I've been spending my last 2 weeks playing with a different setup. So we're gonna try this setup out and see how we do with the show today. It could be an unmitigated disaster, or it could be awesome and cool. So we'll see. Um, but what we do have is we've got James with us today. James, how you doing, man?
Hey guys, how's it going? I'm doing well.
All right. So, I was gonna do a demo of stuff, and it blew up in the last hour, and I gave up, and I renamed the show to just be Q&A. So we're just gonna chat today instead. So we'll still have the show. We'll go through like news and stuff and see what's going on in the world. But no demo today. So if you came here for something fancy, I don't have it. I'm sorry. I'll next time. I will have something for next time. But as always, let's start off with our community news. Oh, and see, I'm already messing up. This is supposed to be showing not this window, but this window. Yay! Alright, so we have our agenda of stuff to go through today. So let's start off with release news. 2.6 Beta 2 is out. Everyone go get your Beta 2 on. Try it out. Bang on it. RC1's coming next week, and then the release of 2.6 is the week after that. So it's definitely time to get your beta on, to get your feedback in. There is one known issue I want to highlight. There's an issue with some destroy code that we've narrowed down to. We have two things that are both trying to go, hey, if I'm the last one talking about an application, I'll remove it. But because we've parallelized some work, so they're happening together, they both go, oh, I'm not the last one. The other person has it. And so neither one of them cleans it up. The good news is that if you play with Beta 2 and you get in this situation, Beta 2.6 introduces a remove application dash dash force command, which you can use to remove the application and force it away. So if you do hit this condition while you're testing Beta 2, fear not, you have a new tool anyway that you can help test out and practice with using the remove application dash dash force and get through it. So the release notes are up on Discourse. The logging in by API endpoint is there for you, BD. How cool is that?
Amazing. Absolutely amazing. It's such a long-awaited feature and such a huge workflow improvement for anyone using Juju in a multi-tenant environment. It's excuse me, not multi-tenant, but multi-client.
Yeah,
Uh,
multi-user, multi-client. I know I use it for, I have both the client on my laptop and on my desktop here. Multiple users, if they come in from somewhere else, being able to actually just use your password to authenticate is a good thing. So for sure.
it's amazing.
Woo-hoo. All right. Let's see. Next up, I wanted to highlight promulgation of Mailman. So anyone who runs a mailing list out there, oh, this is just going to keep going to the wrong window. I don't know why it won't let me do it right. Huh. All right. Well, this may not last forever then. Let's see. So, Mailman Charm is out there and available. If you want to run your own mailing list, there's two charms for it. There's the kind of core side and the website. It's split into two pieces now, but it's definitely something to play with if you're into that. And then I wanted to highlight James' post. Actually, I think it's just from today or yesterday around the Juju controller configuration, because this is something that's been a very common pain point in the past, which is, hey, when I bootstrap, I can set all kinds of options, but it's hard for me to know what options I can set. And we've always said, yeah, that's tough because the options you can set can depend on what kind of cloud you're going on to. Is it, the controller itself? Is it cloud parameters? Is it model parameters? Like there's a bunch of different things and it can be a bit variable. But Peter did a good job and he highlighted that he added a documentation page called Configuring Controllers, which goes through and lists out the options and what they do and everything. So it's a really good resource that helps clarify some of that. And I know it's a long-standing pain point. So I just want to highlight that that's out there and available and for folks to go try. And obviously, like everything else, provide feedback, updates, whatever we need to make that better and more useful. Cool.
Yeah, that's great. Great documentation right at your fingertips. Looks like I just missed it, but it's probably good to expand on some of those topics anyway. So, all for the
Yeah.
better, right?
Oh, definitely. Next up was your other post, James. I wanted to kind of highlight playing with the HA controllers with valid certs, which is an interesting problem. And you go a bit into your use case, and I mainly wanted to highlight it because I think other folks kind of have this. And like you say, with the logging in to existing controllers, and with trying to make 2.6 really good for multi-user and some of the improvements there, this is something that falls under that umbrella. I think that making sure we better document how to use this setup with a proper cert, with an HA controller, with multiple users and everything, getting it all with a nice DNS name and everything is a really legit use case for things. So I think I've got to go play with and test some stuff. I was trying to get ready for the show today, so I didn't have a chance to run through it yet, but I know I want to do that later on here. But you have to let us know how that works for you. And see what we can do as far as getting some good tutorial-y type, documentation updates on how to do this right.
Yeah, that'll be a great little fallout of deep diving this. Is that hopefully we'll have a really tried and true and well documented way forward there.
Yeah. No, and what's fun is we're starting to get to a point where we've done some stuff with Jazz, where Jazz was kind of a hosted way to do things, but as people are really scaling up their own Juju infrastructure, they're running into their own almost mini Jazzes, where they're trying to run a good stable set of HA controllers and have their own internal infrastructure around it. So let's see. I also have next up this post from Merlin around can't remove a model in the last application hanging and dying. This is just to highlight that 2.6 -- force being added across the board for things from remove application, remove unit, remove model, and letting folks. I've been promising for a while that this is coming, it's coming, it's coming, and it's getting there. So I just wanted to have folks again try that in 2.6. Make sure all your stuff can get destroyed or brought away. If you can hang it in some way that the force doesn't work, let us know. But it's coming. It really is. I promise.
Right on.
All right. So that is kind of my interesting stuff from discourse and conversations to have and stuff around there. I did want to give you a chance, James. You had a post around some Spark stuff you were doing, and I was kind of curious if you wanted to share what your Spark stuff was looking like and what folks can do to jump in and give it a run through and see how it works.
Yeah, I can give a quick little live demo if that's all right.
Sure, shoot.
Okay, on the spot. I guess I'll share my screen if that's all right.
Totally.
Okay. So as you're mentioning the post on Discourse, there are two tutorial posts on provisioning Spark workloads using Juju. This is the fallout of the last 2 weeks of our team really stomping on these Spark charms and the Spark charm and the base layers that it uses, and getting it to work in a very functional and generic yet usable way. So you can easily kind of navigate to Discourse and see the Spark workloads using Juju Part 1. This just walks you through getting a single instance of Spark deployed, which runs the master, worker, and history server processes. And that's kind of just the bare minimum. You can just deploy one unit of Spark and have everything you need to execute against it. So after the Spark Workloads Part 1 tutorial, there is another tutorial that I've posted, Spark Workloads Part 2, which is really a expansion on the first tutorial, kind of takes you through deploying Spark with some additional components, the particularly the Conda Charm and the Jupyter Notebook Charm, and a simple monitoring stack that I'm sure everyone's well aware of. I've kind of taken these components and I'll bundle them together. And this part 2 tutorial takes you through kind of deploying Spark in a more expanded fashion with monitoring and dependency workflow tools using Conda and a Jupyter Notebook deploy as well that can execute against Spark. So simply put, I can kind of spin this up and talk about it real quick. We can add a new Juju model, and I can add tags maybe to this model to tag my resources, and then I can add some a space to this model to kind of depict where what network things will land on. And so now I have this nice little empty Juju model that's initialized with the bare minimal things that I want my model to have. So first off, let's just kind of go ahead and get a minimal Kubernetes bundle stood up. And all I've done to this Kubernetes core bundle is basically specify an extra constraint to make these instances land on the network that I want them to. And so with that said, I can go ahead and deploy this Kubernetes core bundle. And
wait, so hold on. So all the Spark that you're talking about running here and everything, these are all then Kubernetes charms running in a...
So I'm just kind of deploying this while we get the other things deployed, so we can turn around and use it once we have the notebook up. So this whole deploy basically doesn't run on Kubernetes natively, but the Jupyter Notebook and the underlying Spark service can utilize Kubernetes as a scheduler.
I see. Right.
Entirely external to the notebook. So that is kind of one of the objectives that we're working on, is getting the kind of enterprise gateway running on Kubernetes and getting the kind of native Spark deploys going there. But right now we have these external deploys working on Kubernetes, which is just really a thing of beauty. There's kind of just been a ton of learning that's gone on from everything from creating Docker images to how we're using storage and networking with Kubernetes. But we have a very basic Docker image, oh goodness, in this repository Spark on K8s. And what this image does is it basically, I've built a Spark image from the unmodified Spark 2.4.1 source. And that we kind of have this image built. There's a few extra components to this. I'll just go into it at a high level. To have a Docker container run Spark and to be able to execute Spark jobs on Kubernetes, you need to kind of have the Spark components in the Docker image. And so we can easily get those by building a Docker image from the Spark source code. So I've done that, just kind of posted it at my own Docker Hub repo there. Then I have this rest of this Docker file, which basically pulls in the minimal dependencies for things we need to actually run Spark in a useful way. We kind of also need these Hadoop libraries. So we kind of pull those in the Docker file, and then we also pull Conda in the Docker file, so that we have all the same things in the Docker image that we would need to have to execute our workloads. In a Spark context, we set some extra environment variables. And then from this Docker file, we've then been able to produce a kind of a way to deploy and package the Hadoop and Spark and other like workflow dependencies, and then kind of use this Docker image with Kubernetes and Spark. So let's also get on with things quickly and deploy our Jupyter Notebook.
Seems like you might have typed this out a few times, huh?
Oh yeah, enough times to make some really good docs. So anyway, so we can just, without even any extra configuration, I'm just going to deploy the upstream version of the OmniVector Jupyter Notebook Charm and kind of get that into my environment here. Not enough times. And so with that, now our environment contains will contain a Jupyter Notebook deploy, and it also will contain a Kubernetes deploy. Let's also, while we're at it, spin up a standalone Spark cluster. So we'll also go ahead and deploy Spark to our same NAT space. We'll make these instances a little bit larger. And for kicks, let's go ahead and add the Spark storage. Now, this kind of brings us to a key point and a key functionality of these Spark charms. Spark standalone needs local storage to be able to do work in. And if you're executing against remote storage endpoints like S3A, Spark is going to need some kind of medium to pull things into and do processing on. And so I've used Juju storage to facilitate the Spark local and the Spark work storage needs. And so we can access those by just deploying the Spark charm with storage and specifying Spark local and Spark work.
Nice.
And we'll give ourselves a Spark cluster of 5 units. And just like that, now we kind of have these 3 separate components. We have a Jupyter notebook, and we have a Spark standalone cluster, and we have a Kubernetes cluster standing up. And so we kind of have 3 separate execution environments, if we so please. And to maybe just highlight a few quick points about this, we can look to the Jupyter Notebook charm, and it will help us, the charm code will kind of help us understand how this is possible. If we look at the layer.yaml for the Jupyter Notebook charm, we can see that it is built using the layer Spark base and the layer Hadoop base and the layer Conda API. So by default, this Jupyter Notebook charm has all of the Spark dependencies, all of the Hadoop dependencies, and the capability for a user to specify any extra packages that they may want in their Conda environment by using these charm config. And so with that said, we can kind of turn around and see our environment deploying here. There's one more component we will add, and that is the Conda, Anaconda charm, which allows us to install our dependencies and our Conda virtual environments for our Spark jobs to execute using the Anaconda Python as the PySpark Python executable. So we can, with that said, we can also deploy OmniVector Conda.
And that's going to give us some of like the libraries and things for doing some of the data processing stuff, right? Like that's particularly what Anaconda is providing, like a Python environment with a lot of data processing slash other kind of libraries and tools available to help us crunch our stuff. Or
it's like a Python package manager for big data applications.
that's fine. Yeah, no, I just wanted to kind of give some background. Not everyone may be familiar with the Anaconda side of the Python world.
So if we want, gosh, there's I better like watch what I say, or I will say something I don't know. But Anaconda allows us to kind of have these streamlined, some of them optimized with C compilations and kind of packages that are all versioned and tested to work well in the Anaconda big data processing context, more so than just like your upstream pip packages. And so Anaconda has kind of become a de facto package manager in like the big data workload environment. So it allows us to specify in a Conda environment manages both pip packages and Anaconda pip packages. It's slightly confusing, but if we have our own pip packages, let's say that are our own private repositories that we develop this code to process big data on Spark or on any system, we can use this Conda charm and specify Conda extra pip packages and give it some get plus HTTPS to our own, our own GitHub repo.
And then pull down and build and install that into your environment for you so that it's available for folks to run against.
Entirely.
Gotcha.
So by default, you basically need this Conda package called ipykernel. It's what allows IPython Notebook to create a notebook kernel out of the Conda virtual environment. And so I'm just going to ensure that we have ipykernel and maybe a few other things that we'll need, like PySpark. And since we use mini Conda in the charms, it's a very minimal version of Conda, so we just don't get this massive dump of packages that we don't need. If we want pip and some other things, we can specify them there. But at a very basic level, I could kind of just specify some basic packages there and deploy this charm under the name Conda. And now I will also, just as an example, deploy this charm under the name PySpark, and I will add an extra package, and maybe two. So now we have the Conda charm. It exists in our environment with two different sets of Conda packages, and you can see each Conda charm has a different name. The initial one assumed the name of the charm Conda, and the second Conda deploy is named PySpark. And so with that, you can kind of look back at our Juju environment here, and the charms are kind of executing and still spinning up. And so we're just gonna let them do their thing. But so maybe something to note while we're here, the Spark charm also uses, as well as the Jupyter Notebook charm, a Spark tarball and a Hadoop tarball as resources. These resources are each around 2 to 2.5 gigs.
Oh, geez.
Or excuse me, 200 to 250 megabytes.
Okay.
And so we have almost a half gig of resources per charm. And so when we do a deploy like this, something that happens is all of the charms try to reach out and grab the resources, the basically 2 tarballs that make up a half gig of resources from the controller. And there's this interesting issue we've encountered where we haven't really dialed it in enough yet to be able to say exactly what it is, but all of the things aren't really able to grab the resource at the same time. So we've implemented a nice little way for the charms to kind of wait for their turn to grab the resource. And as you can kind of see live here, the charms were spinning, waiting for a resource, and then each of them kind of got it, and the next one anyway. Now we have this nice little Spark cluster here.
Do me a favor, though. We should make sure to file a bug around that. What I can see is the resources are cached on the controller, and they're stored in the database so that they can be reused and shared to additional units or future units or whatnot. And with a large resource, and I could easily see us being able to kind of saturate the pipe between the units and the controller. And so, if there's work that Juju should do to help better manage that pipe in a more sane way, then that's something we should definitely get a bug on and make sure that we're updating in the future or whatnot. So, it's very cool that you're pushing stuff like that, though. I mean, that's.
Thanks. It really exacerbates itself around 50 units.
Yeah, exactly right. So 50 units grabbing 250 to whatever 100 megs. We're talking about, It could easily be tens of them grabbing, basically gigs of data piping through at a time. I could see some pipes going, hey, I'm only a 1 gig connection between these things here. We're full.
Totally. So, yeah, we found a little workaround to kind of make this deploy more effectively in larger workloads.
Mm-hmm.
That deploying the Spark units by adding units of 5 at a time is a
Right.
much more feasible way than 50 at a time. So either way, we can see all of the components are kind of settling here. Our Jupyter notebook is now active. Our Spark cluster, standalone cluster is up and running. Our Kubernetes cluster is almost there. And we have our Conda charms deployed to the environment. So I guess it would be a good time to just kind of hop right into the Jupyter notebook and see what's
Say,
there.
what are we gonna do with it? Let's do something.
It's amazing. It takes a good amount
So
of effort.
in general though, right? We're gonna use our notebook to create kind of mini jobs, to parse out some, break apart some data or whatnot against using the Spark to help do the job processing and stuff and get our results and stuff back into our notebook for
Or
our use.
into
And then with the whole Jupyter notebook on and Kubernetes, it lets us basically create multiple notebooks for a mass of users, say a team or department, or even like a classroom or something, where they could each have their own notebook spun up on the Kubernetes cluster to create their own tasks and jobs, right, against the same shared data set and the big data pipeline. Right? Is that a fair summary of what we're assembling with all these components here?
totally 3 different ways to run Spark jobs is what you're looking at right now. Can use the Spark local scheduler, just executing on the Jupyter notebook alone. You can use the Spark standalone remote cluster using the Spark standalone built-in scheduler, or you can use the coarse grain scheduler with Kubernetes, using Kubernetes as a backend. And so 3 different ways right here, and probably just another, we could probably look at execute a very simple line or two of code against all of these just here in right now. So first things first, we can access our Jupyter notebook. We have our VPN on.
I think I can. I think I can.
Yeah, there we go. And so here we see we're presented with this beautiful Jupyter notebook, and we can kind of the conda bits work. There was just a whole load of work making this kind of the system D process run the Jupyter notebook with the conda, the correct thing source to have it facilitate the whole conda functionality here. But what we see is we have 3 conda environments. The root and conda are those just are kind of default environments, and then the Jupyter notebook creates its own conda virtual environment for the Jupyter notebook to execute in. Now, none of these have any dependencies in them that will let us access Spark or PySpark or run Spark jobs. And so we look in the, if we were to create a new notebook here, we see kind of the only environments that we have to execute in are the ones that we don't want to use because they don't have our dependencies. And so what we can do, we know we have some special tools over here. We can make the relation between the PySpark charm and the Jupyter notebook charm. And can kind of see that relation start to kick off here with the agent initializing. And what's actually going on there under the hood is the Conda charm is creating the Conda virtual environment and installing the dependencies that we have specified in the charm config.
I'm just
And
playing
yeah,
with the window to try to get the fonts a little more readable. So I
really
apologize for.
big, a little big. There we go.
No, no, you're fine. Actually, bigger is better. I was trying to grow things a little bit to make the text a little bit more process. It's fun trying to get the right size windows of everything. Experimenting with the new toys, the new streaming toys. So
So if you see in the log here now, Conda environment location, the following packages will be downloaded. This is mini Conda downloading the minimal set of Conda packages for Conda to exist. And we can see the log exhibits that. And then we can see the log also exhibits Conda creating the PySpark virtual environment. We can also see the dependencies we specified here: Elasticsearch, IPyKernel, NumPy Pandas, and PySpark 2.4.0 are now all being installed into the Conda virtual environment that exists on the Jupyter Notebook machine there. And so with that, as soon as the environment is kind of done initializing and installing the packages, we will be able to, and we already can, see our new PySpark environment kind of populate here. And we see it kind of is just still installing the packages or what have you. But if we refresh as it goes along, we should kind of see the rest of the things that we want to see in our virtual environment populate here. And just some of these are slightly timely, but
no, that's fine. That's cool though. So that's a relation with a kick for sure. So that that relation kicks off a nice chunk of work.
And there's a bit more we'll look at just momentarily. I know we're running a little long, trying to shorten this, but so looking in here, we now see more and more. Looking into our dependencies, we can kind of see that more and more things are becoming available, and hopefully our environment will finish soon. There's PySpark, one of the larger dependencies.
Yeah, it's working on it. Yeah, see there, 200 meg, 200 meg, 200 meg. Yeah, you've got a good gig of stuff coming down.
And so while this is going, let's go ahead and also relate our other Conda environment, which is just titled Conda. And so now we have two separate Anaconda environments that will exist on the Jupyter Notebook Charm with two separate sets of dependencies. So if a developer so wanted, they could have kind of an arbitrary number of separate Conda environments attached here, just as charms via relation. So we see our PySpark end is now installed. And if we kind of go back to create a new Jupyter Notebook, we can see now
we have options.
We've got options, which is great. And so you can kind of choose this option, populate a new Jupyter Notebook here in the Conda virtual environment that we want to be running in. And then there's a very simple snippet of code we can run to kind of just verify everything's working. And so this
copy and paste from a tutorial. All right.
This code will execute against the Spark master. And so using standalone Spark, which we have, we can execute against it remotely. But what's even cooler is just by having this Jupyter Notebook existing and our environment with the PySpark dependencies and the Spark binary and Hadoop binaries on the local file system, this Jupyter Notebook doesn't need a Kubernetes cluster. It doesn't need a Spark standalone cluster. It can execute the job all by itself. So let's go ahead and do that.
Which is kind of great for like prototyping and testing that your code works and all that kind of setup, and then run it against the bigger data set or the full stuff on the full cluster, you know, as after you get all that kind of tweaking of your script and stuff set up, right?
100%. And if we kind of, it's already finished.
There you go.
And so we could see we had the dependencies to run PySpark, all packaged in the environment, and we were able to execute this job. Looking at the resources on the Jupyter Notebook machine, we can see that the Java Spark process is actually launching here locally. And so that's kind of our verification that, hey, we spun up this one instance, and now we can execute, kind of get all of our big data processing dependencies installed on that a single instance and run Spark jobs just on that bare minimum Jupyter notebook. So kind of the two next steps that can go really quick here is we'll need to get those same dependencies that are in that Conda environment onto the Spark nodes. So if we wanted to execute, instead of executing against the local Spark binary, we can now execute against the remote Spark standalone cluster by just specifying the master IP here, because all of the nodes now have the same dependencies in the same place, in the same virtual environment that our notebook has. And so we can kind of rest assured that they will be able to execute the jobs that we give them. So we'll go ahead and specify the Spark.
Okay, there.
Thank you. Spark notebook or Spark master there. Look over here, we'll kind of just wait for the Conda charm to initialize. And while it's doing that, I'll just prepare another cell that will be the cell we use to execute against Kubernetes. And with the Kubernetes execution, there's really only one more config that we need to add here, which is just telling changing the Spark master to point at Kubernetes. Yeah. Our Kubernetes master. So, and telling it what container image to use with our dependencies. Like we were talking about initially, created this nice little container that has our gaps in it. And so then we tell it what container to use, we tell it where the master is, and we can then execute against Kubernetes, just like in this cell, we are going to be executing against the standalone. The only difference is we used the Conda charm to get our dependencies onto these nodes. And in the Kubernetes example, we've already pre-packaged all of the dependencies that we need to execute our job into the Docker image.
The image there, yeah.
And so with that said, we kind of just, we just need to fill these things in, and we'll be off to the races.
So thinking ahead, could a Juju Kubernetes charm for this update the dependencies and kind of relaunch itself, or because the images are preceded with the dependencies, would it not be able to do that? You would have to generate a new image. We can generate a new pod spec on config and stuff, but not rebuild a new image in the Kubernetes world, right?
So exactly. So changing the core underlying dependencies that the image is built with it entails rebuilding the image and repulling the image. But a lot of times, the underlying dependencies that you're doing your data analytics code with are kind of are tagged and released, and a lot of the code that changes is more or less like notebook code or what we would call application level code. And so in this context, I think in the Kubernetes context, we need to set one more environment variable, and we can be off to the races here. Kube config. This is going into the next tutorial. Will show kind of what I'm showing now, how to expand this use case to Kubernetes. Just go ahead and give the Spark environment the location of my kube config. And let's go ahead and quickly pull down our kube config.
And this is pretty standard just as far as getting your config data out from a Kubernetes cluster that you bring up so that you can use your own Kubernetes tools and stuff against it. So
100%. And now I've got that config file local. I'm just going to go ahead and move on up to my Jupyter notebook. Okay, and kind of hop into that Jupyter notebook. Make sure that things are in the right places. Right permissions. small modification should be ready to go there. Let's look back at our environment. We see our conda env is now installed on all of the Spark units, which is great, which means that we can now kind of, I'm just going to go ahead and remove this, or I don't want to execute this cell. I just want to execute this cell down here. I'm going to save this and kind of restart this. Now that we're executing against a standalone cluster, I'm going to go ahead and beef up the number of samples a little bit. We see we have our Spark master URI filled in, and we can go ahead and execute this cell. And if we look at our Spark master, boom, and of course.
It's all live demos. It's the way it goes.
There we go. So that's how it works. We can kind of just destroy this. Let's while we have everything set up here, let's actually try to execute against the Kubernetes cluster. Let's restart this. And while that's executing, we can kind of look at our kube, probably move this config that I have here to my own local kube config, and then I can start a kube proxy, but I'm in a virtual machine.
Oh, okay.
And I can just execute that command and get things local to this system, then we can do what we wanted to do. From another system, fill in these pieces.
Oh, we got data back.
Who did we? Let's log into the kube proxy. Our config so we can see our dashboard. Oops.
Show me all your secrets.
Okay, and here's our beautiful kube dashboard. Here's our notebook, which we can see executed successfully. Let's go ahead and kick it off one more time, just for sakes, and look back over at our kube dashboard, at our overview. Come on, guys. And we should be able to see, Jupyter test.
Yeah.
There's our pods that have already launched and completed, it looks like. And wow, what if we want this?
Need more zeros.
Again, I'm kind of refreshing the workloads, and here is our two container images that we specified right here. Sure. Were pulled down onto the Kubernetes worker node and started processing these what we've told Spark to parallelize, and we can see this beautiful little thing happening here, where our Jupyter notebook is actually just utilizing Kubernetes as a backend and scheduling our workload to run on it. So with the exception of our little Spark standalone slip up there, you can see how this these few charms between the Spark and the Conda charm and the Jupyter Notebook charm allow us to really move our big data development and operations between three different substrates very, very easily. And that kind of concludes the presentation, the unofficial presentation that I didn't have for you.
Oh, you did good, man. You covered me up really good, man. You did great with my demo blew up an hour ago, and you had an awesome demo just waiting in the wings. I didn't even know. But so I appreciate it. That's really kind of cool, and it's great to see how you could, you can see the spectrum there of, like kind of development, testing, kind of doing it at production, at scale. I mean, you could really set up a nice little environment for folks to work against, pretty nice and easily. And what's great is that the nice portable charms in different environments. Always love when a relation kicks off and makes things kind of does a crap ton of work that would have been a bunch of manual copy and paste otherwise, right? Like that. So,
That's what it's all about, man. I agree.
yeah, awesome. All right, well, with that, I think we're gonna wrap this show up for today and for this week, and see you all in 2 more weeks. So, till next time, everyone, have a great time. Talk to you later.
Thanks, guys.